Let's actually graph a hyperbola given an equation. So here's a hyperbola, and the first thing I note is the center, because in my mind, once I have the center, I work from there to get all the other pieces of info. And the center is going to be at, well, it looks like a shift left 3 and up 2, so the center is at negative 3, 2. So there's my center. So what else is important? Well, if we get that central rectangle going, then we should be able to find, we should be able to get the asymptotes, the vertices, and then therefore a nice graph. So I will note that my a squared always comes first, so a squared is 4, which means that a is 2. It's underneath the y, it's underneath a y minus 2 squared, which means that I need to move vertically a distance of 2 away from the center to get either vertex. So moving 2 in that direction and this direction gives me both of my vertices. So the hyperbola is going to go through either one of those points. And this is our b squared, which means that b is 4, and horizontal movement 4 on either side of the center will give me the endpoints of the conjugate axis. But what I'm going to do now is just sketch this central rectangle here. I'll dash it in, because it's not actually part of the hyperbola, it's just a scaffolding we use. So now we know that my asymptote is going to go through. It's going to go through the center and through the diagonal, or through the corners of and the vertices, I could say, of this rectangle. So if you dash those in, then we've got a way of actually sketching it in blue, sketching my hyperbola. So we know it goes through there, and it's going to follow those asymptotes. Okay, it says include the asymptotes in the focal points, so I've done that. Now I'm actually going to write equations of my asymptotes because it's good practice, since these asymptotes don't go through the origin, so it's slightly more difficult. So I'm going to draw your attention to a very important form of an equation of a line, which is point slope. So we know that the slope of one of these asymptotes. Let's look at the one that has positive slope. Well, to go from the center to the upper right-hand corner of that rectangle, you move up 2 and right 4. So the slope is up 2, right 4, which I could write as up 1 over 2. And all I need is a point on this asymptote, and the center is a nice point to use. So the center has coordinates negative 3, 2. So I'm going to write x minus negative 3, which is x plus 3, and then y minus 2. So there's one asymptote. And the other one would go through that central point again, but it would have a slope of negative 1/2, moving down 2 and right 4. Okay, now let's find the focal points. And I think what we're going to do is use that good old Pythagorean identity again. So a squared plus b squared equals c squared, so 4 plus 16 equals c squared. So the square root of 20 is what c is equal to. And we want to move along the transverse axis a distance of root 20 from the center up and down. So the center is at negative 3, 2. So the foci should have the same x coordinates. So I'm just going to start at the center. I'm going to move up a distance of root 20, and I'm going to move down a distance of root 20 from that point. Now root 20 is in between 4 and 5, so it's like -3, comma, some distance in between, some number in between 6 and 7. And if you just move, so -3, let's just plot -3 like 6.5. -3, 6.5, be like somewhere there. Call that focus 1, I guess. And then -3, so 2 minus a number like in between, a number in between 4 and 5 would be, so it would be like -3, -2.5 roughly. So there's my second focus. And again, those are not part of the graph, but they are part of the geometric definition, so we'll want to include them. So there's my graph. There are my asymptotes and equations, and there are my focal points.